Homework number 5. This is part 2. So we just barely began last time to talk about it. So let me make one up. I mean, you have your ones in the homework there. Let me, how about, let's start with a multiply one again. How about if we take 47 and 36 multiply in base 8. Multiply in base 8. So, yeah, so what did we do? I'm trying to remember. What did we do last time to help us out? Did I count on the side? Yeah. That seems kind of dumb now, but why? There must have been a good reason. So I went 1, 2, 3. Well, I guess so. 4, 5, 6, 7, and we're in base 8, right? I'm in base 8, so I'm not going to write 8. Anytime you're about to write, you put a 0 and you carry, so it's 1-0. Then you go back to adding 1 again, right? 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8. No, make it 2-0.
Well, you just wrote like 8 equals 1-0, and then like 9 equals. You just did everything above 8, and then put what it equals.
Okay, I just started at 8. Yeah, that makes sense, huh? Yeah. Sure. Yeah, so this is 8, actually, huh? 9, 10, 11, 12, 13, 14. That looks like weird math. 14 equals 16. But you know what I mean. 14 regular equals 16 base 8, huh? And this is the number 15. This is the number 16, etc. Okay. So anyway, I'm not sure that's going to be. I don't know. Now I'm wondering why I did that. Okay, let's start. Let's just crank through this one. Let's see what happens. 6 times 7 is 42. You can use calculators on everything. 6 times 7 is 42. But I can't write 42. Yeah, that's not going to be helpful, is it? What's all that stuff there for? I don't see why I did that before. So
we're supposed to look what 42 equals.
Yeah, so that's what we need to do. Not all that. I don't know what I was doing. Anyway, whatever. So 6 times 7 is 42. Good so far? 6 times 7 is 42. But, of course, I can't write 42. It's, I got to write it in base 8, right? 42 is the normal 42, the base 10, 42. I got to change it to base 8. So how do you change 42 to base 8? Well, probably help to write out the base 8 place values. Remember the 1's place, 8's place, 64's place. Don't need any of those. Good so far? Remember base 8? So when we go into a foreign base system, we always start with the 1's place, and then we just go times 8, right? Okay. And so until you get past your number, you start with the biggest one you can. Remember this? So how many 8's go into 42?
5.
Yeah, 5 8's. That's 40. You can use a calculator again if you're rusty on some of these times tables. 5 8's is 40, and that leaves 2. So 42 normal becomes 52 base 8. Good so far? So we just have to constantly convert everything we do from normal into the foreign system. So I'm going to write, instead of writing 42, 6 times 7 is 42, I'm going to write 52 because I'm in the base 8 system, huh? Good so far? It's making sense. So can you do the next step? Try the next step. 6 times 4, add 5, right? 6 times 4, add 5. What's that? 25. No, 29. 29. And then you got to change it, right? You got to change that. 1's place, 8's place, Change that to base 8. I'll give you a second. I just multiplied 6 times 4 and added 5, just like normal, everything normal there, right? Normal multiplication. 6 times 4 is 24, add 5 is 29. But then I got to remember to change that to base 8. So how many 8's go into 29? Would it help if I showed the long dividing? How many 8's? 3. So that would be 24 remainder 5. So that's 3 with 5 remaining. Right? 3, 5. Because you can double check that. That's 3 8's, 24, and 5 more, 29. That is a 29, isn't it? Is that okay? So that's 29. And so then this is what I write down rather than 29. Right? This is 29 in the base 8 system, huh? So I write 3, 5 like that. Good so far? And now we're done. The 6 has had his turn, so to speak. We're done with the 6. He's multiplied both the 7 and the 4. He's done. And now we're going to start with the 3. We're going to multiply first off the 7, but we remember it's really a 30, or 30, sort of, if you want to say it that way. But so we got to add 0, huh? Because we're really one place over. We're really multiplying by 30, not 3. So, okay. And so then we go 3 times 7. 3 times 7, 21. But then again, got to convert it, huh? So go ahead. I'll give you a second. Can you finish? Okay. So let's keep going. So the 21, change that to base 8, right? And so we say, okay, so how many 8s go into 21? Just 2 of them, huh? That'd be 16, remainder 5. So 2 8s, 5 more. Everybody see that 2, 5, base 8 is the same as 21? Right? We can double check it. Because 2 8s is 16. Again, if you use calculators, anything you're rusty on, it's time to 2 8s is 16, and 5 more, 5 times 1, 5, is 21, isn't it? That is the same as 21. In the base 8 system, I mean. Is that good? So, okay, so 2, 5. So what do we do? So 3 times 7 is 21, but 25 in the base 8 system. So how do you write the 25? You write the 2 here and the 5 there. Isn't that what we always do with multiplication? Good so far? And then 3 times 4, next step. 3 times 4 is going to be 12. There we go. 12. Well, I'll write 3 times 4 and then add 2, huh? So 3 times 4, add 2. What's that, 14? Times 4 is 12, add the 2. Yeah, 14. But again, we've got to change that to base 8. So how many 8s go into 14? That's just a single 8. Can't do 2 8s, huh? So you do 8, and then how many left? 6. Is that okay? We just kind of go straight to it? 1, 8, and 6 more makes 14. That is a 14, right? Okay. So 1, 8. Now, yeah, I'm thinking there's not an 8 in base 8. Yeah, I'm just crazy. All right, good. So now we have to add them up, right? And you know why that's true, because because we multiplied the 47 by 6, and that's the top row, and then we multiplied the 47 by 30 actually, and that's the bottom row, and now we have to combine them to have the whole 36 times 47, right? So now we add them up. So 2, 5 and 5 makes 10, but I'm still in base 8, huh? So I can't do 10. What do? I don't do 10 either. 10 means carry a 1, but what does that 1 really mean? It means 8 when you're in base 8. It doesn't mean 10 like it normally does in normal base 10. So that's 8. So again, 5 and 5 is 10. That's 8 carried away, 2 left over, because that is 10, right? 8 and 2. That 1 represents 8, remember, right, in the base 8 system. Okay, and then 1, 3, and 6, what's that? 10 again. 10 again, so that's 8 carried away, 2 left over, and 1 and 1 makes 2. You guys are right. 4 2s. So it's not simple, is it? A lot of converting constantly. How are we doing? Questions on that? How many got that? Let me just want to see how much I should speed up, slow down. About 2/3. Okay, let's do one more before we go into dividing. They're harder when they're higher bases too. So let's try. How about 46, 53, base 7. So let's try that one. So go ahead and work with. Okay, so 3 times 6. Go over here on this side, I guess. 3 times 6, 18. But we can't write 18. Got to change to base 7. So 1's place, 7's place, huh, in base 7. So how many 7's in the number 18? You can long divide. 7 goes in 18. 2 times remainder 4, right? So that's 2 7's is 14, remainder 4. So 18 becomes 24, base 7. So I write 24. We good on the first step? All right, next step, we go 3 times 4, 12, add 2, 14, but again, we got to write that in base 7. So 14 into base 7 is how many sevens? 2 sevens no more, huh? It's 2-0. 2 sevens no more. That is 14. So 2-0. So there's our first row. We're done with the 3. He multiplied both those numbers. Okay. Now, we'll go on to the next one. So now starting with the 5, but it's really a 50, so we're going to add a 0. So 5 times 6 is 30. Whoops. 5 times 6 is 30. And then we got to change that. One's place, other place. So how many sevens in 30? 4 of them, huh? That'd be 28 leaves 2. So it's 42. 2 base 7 has 4 sevens, which is 28, and 2 more makes 30. That is a 30, isn't it? So bring that over. So 5 times 6 is 30, but we write the 30 as 4-2. So I go 4-2. Good. Last step. 5 times 4 is 20, so we'll come down here. 5 times 4 is 20. Add 4. 24. Change that, though, to base 7. So 7 goes into 24. What's that, 3 times? 21, remainder 3. So it's 3 sevens, remainder 3. 24 is 33 in base 7. Right? So 5 times 4 is 20. Add 4. It's 24. Change it. That's 3 sevens, 21, and 3 more. That is 24, huh? So 3, 3, base 7. So 3, 3, and now we add them up. And start over here on the right. 4 and 0 is 4, 2, 5. Oh, good. We never had to worry about hitting 7 and carrying or anything on the adding. So there we go. 3, 5, 2, 4. We good? Questions I can answer on that multiplying? So if that was too quick, this will be on YouTube. You can always practice it again. You know, I'll ship this out to YouTube after class. You can practice this, go back over them, try them again. You know.
4 into 1, 5, 3, 2.
Oh, that's right. I just totally ran out of time, huh? 4 into 1, 5, 3, 2. Okay, let's do it. So let's long divide 4 into 1, 5, 3, 2. Now, long dividing is even harder than multiplying.
It's base 6.
Oh, thanks. That's important, huh? Base 6, thank you. So, okay, so base 6, yeah. So yeah, this I would do something to help out in the beginning. So, and that is, I would set up things multiplied by 4. Because basically you're going to constantly be asking how many times 4 goes into stuff, right? Like right away we're going to look and we're going to go, how many times does 4 go into 15? Of course, we think 3, but that's because we're thinking base 12, right? I mean, normal base 10, because 3 times 4 would be 12. But we're not sure that's the same in base 6. So anyway, so whatever number you have out here, you have to go over on the side and find out, go times 2, times 3, times 4, times 5. You really need to find the 4s. You got to know the 4s times tables in base 6, I mean. So 4 times 2, of course, is 8. But how do you change that into a base 6, base 6 number? Am I totally confusing you at this point? So whatever number you're dividing by, take that over to the side and go times 2, 3, 4, 5. Go a little ways anyway. And oh, yeah, why don't I go to 6? Because there's not a 6 in base 6, huh? Yeah, so stop right there. That's how you know how far to go. Just go, and why didn't I do 1? Well, because that's so easy. We know 4 times 1 is just 4. I mean, you can do it if you want. It's not anything hard for you. I just want to get you down the ones that you need. So 4 times 2 is 8. Let's change 8, though, to base 6. So what is 8 in base 6? How many 6s? 1, 6. That's 6. And how many left to do 8? 2. So 1, 2. 4 times 2 is 8, which is 1, 2 in base 6. Okay, let's do the next one. 4 times 3, we know that's 12. But in base 6, 1's place, 6's place. How many 6s in a 12? 2 6s and no more. It's 2-0. Better leave a little more room here, huh? So there's the first one, second one, times 4. So this is all, 4 times 1, 4 times 2, 4 times 3, 4 times 4 is 16. Okay, but again, we can't have 16. Got to change it into base. So this will really help out. Doing this pre-work will really, really help out. You definitely want to do it. How many 6's go into 16? 2 of them. At least 4 left over. So 2, 4. That is a 16, isn't it? Right? Because 2 6's is 12, and 4 more, that's 16. Okay, only one more, and then we'll be ready to go. So 4 times 5, 20, but we got to change that again into base 6. How many 6's? 3, remainder 2. So 3, remainder 2. That is a 20. 3 6's, 18, and 2 more. That's a 20. Now, so what I'm saying is, let me write a little blurb about what I'm saying. Maybe I should write it over here. When you begin long division in a foreign base, like we're in base 6, like base 6, multiply the number outside by, and that was the 4 in this case, the 4, the number outside, by 1, 2, 3, 4, 5. Stop when you reach the base number, right? We're in base 6, so you don't need to do that. And then change these all. Change to the foreign base. So change them all to the foreign base. So that's what I'm doing on step number 1. Does that make sense? Yeah.
Question, but would you ever actually use times 1? Because you know how, like, if you do 4 times 1, that's 4, but how many times is 4 going to 6?
Yeah, go ahead and do the 1. Yeah, it goes in 1 time. We'll see. We'll see as we go. I think it'll make more sense as we're going. Yeah, so I understand the game plan. So you start with the number that's out here, and you go times 1, 2, 3, 4. So, if they'd put a 7 out here, well, they wouldn't in base 6, would they? If they'd put a 3 out here, I would go 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5. And I stop at 5 because the next one would be the base number, right? We're in base 6, so don't go past that. Or don't even go up to that because there is not a 6 in base 6, is there? So what if I was doing this in base 9? How far would I go up to?
8.
I'd go up to 8, right? You're never going to see a 9 in base 9. Okay, so we set that up, and then now we're ready to do the problem. So now it'll be kind of like normal. So here we go. 4 doesn't go into 1, so you got to go into 1, 5. So 4 goes into 1, 5. Now, we're tempted to think, normal base 10, but don't. Just look over there on the side. What's the biggest amount of 4s I can take? What number can I put up here and write something down here, here, and here, that won't be bigger than 50? If I do 4 times 1, that's just 4. If I do 4 times 2, that comes out 1, 2. That would be okay. That's under 1, 5. If I do 4 times 3, that's actually 2, 0. So I can't do 3. Don't write this in. It's not 3. Do you see why it's not 3 like we would have normally thought it was 3, huh? But 3 times 4 is not 12. I mean, it is 12, but that's written 2, 0. So that's too big. You see what I mean? It's not 3, it's 2. Is everybody seeing that? So I'm going to back this up. It doesn't go in there 3 times, even though we might have thought it did. And remember, the columns are really important when you long divide. You always write you write above the column you're going into. You write the last digit of the number you're going into is where you write the number on the top. So 4 is going into 15, so I write the number above the 5, the last digit of what I'm going into. And it's only 2 times, 4 times 2, because that's 1, 2, which is underneath 1, 5. I can't go up to 3 times because that'd be too big. Good? And so we do that. So 2 times 4, what is 2 times 4? Well, right here. 1, 2. See how helpful? That's already helping us a lot. Good so far. Now what do we do? Subtract. Huh? Remember the whole long dividing algorithm, they call it? Steps, basically. It's just a fancy word for steps. So 3, right? 5 minus 2 is 3. And what do you do with the other numbers? Just bring them down. You can bring them all down or one at a time. It really doesn't matter. I don't know if you were ever told otherwise. It doesn't matter. Just bring them all down one at a time, whatever. Good to there so far? That's our first step along dividing. Good. So next we look right here at the 4. And we say 4 goes into 33. How many times does 4 go into 33?
5.
Yeah, you can see 4 times 5, it comes out 3, 2. So that's under 33, so that's okay. So we do that. So 4 times 5. Notice I'm writing the last digit. I'm not going into the whole 332, am I? I'm just going into the 33. So I write the 5 above the last digit of the number I'm going into. So 4 times 5, we normally think 20, but we write 3, 2. So 3, 2, and subtract. What's left? 1, 2. 4 goes into 1, 2. How many times? Right over here. 4 times 2 is 1, 2. So 4 times 2 is 1, 2, and we're done. Hey, it went in perfect. That's just lucky. Anyway, 2, 5, 2, no remainder. This is the remainder down here, huh? No remainder. So it's not too bad if you have these set up. If you don't, it's like impossible. Is that making sense on that? Because then they just guide you right through the problem. By the way, it's great. It's a good time for me to emphasize. Do you see this right here? How important it was, right? If we didn't know these, it'd be like impossible to do the problem. We would have looked at 4 goes into 15. We probably would have thought 3 times, huh? Because we don't naturally know these times tables, right? Notice, my point in that is, notice how impossibly hard it is to do long division when you don't know your times tables, huh? Like, we don't know our times tables in base 4, so we just go ahead, in base 6, so we just go ahead and write them out ahead of time. Think about those poor kids that are passed on, who never learned their times tables, and they're passed on to long dividing. See, it's just like impossible, right? It's like being just thrown in a jungle and you don't know how to, you never took Boy Scouts 101 or something. You're going to die, right? I mean, if you don't know how to multiply well, dividing is impossible, because dividing is basically multiplying backwards, isn't it? It's always thinking about what would divide and all that kind of thinking, huh? Yeah. I say that just because at some point in your life you'll probably become, many of you, a teacher, and you might even become an administrator, and you'll have a little bit of power, so to speak, with your position. I would encourage you to use whatever power you have to encourage the school system to think about not socially promoting, right? That's a popular thing now, right? If little Johnny, and I've got a little Johnny, but if little Johnny finishes the 3rd grade and he didn't learn anything, but he's getting bigger and older now, he doesn't know how to multiply or even add, and he can't spell, whatever, we're moving him on to the 4th grade because, he didn't hurt anybody in the 3rd grade, and we need to keep things moving. And the parents are putting all this pressure on the poor teachers, and the administrators are putting all this pressure on the poor teachers. And so I know how it is. I know. So anyway, but whatever power you have, I would encourage you to try to encourage, especially in math, social promotion just hurts people, because you go on to long dividing. That's how people's math career gets ruined. Then they move on to long dividing. They never learned multiplying. There's no way they can learn to long divide. Then they just start getting frustrated with math, right? There's no way for them at that point. And then from the 4th grade on, they hate math. They can't do math. And anyway, so then they're on drugs. They're on the street. No, who knows? There's more to life than math. But that is how it can mess you up. All right, so let's try one. So we did a base 6. Let's try a base 5. How about we go 3, let's make one up here, into 2, 1, 4, 3, base 5. Okay. So what's the first thing we need to do? Write out the times tables, right? Because again, you got to know times tables to do long dividing. So you start with the 3, right? So go over on the side, go 3 times 1, 3 3 times 2, 3 times 3, 3 times 4. And how far are we going to go?
4.
Yeah, just 4 because there's no 5 in base 5. Yeah, so the first one's easy. 3 times 1 is 3. I'll do that one. And then just find the other ones, change them into base 5. So 3 times 2 is 6. So change that.
Just do it by 3 to change.
Okay. I throw stuff at people in the front row. All right, so 3 goes into 21. How many times?
3.
Yeah, so we can't do 4 because that'd be 22. That's too much, huh? We got to do this one 3 times 3, right? So here I'll do the columns just for clarity there. So the 3 goes there. It goes over the last digit of the number you're going into. 3 times 3 is 1, 4. Good. And now we subtract. Now you'd be tempted to go 7, but careful. Remember, we're not in normal. We are in base 5. So to do that subtraction right there, how am I gonna carry out that subtraction? I got to borrow from the 2, put a 1, and how much do I bring over? 5. I'm in the base 5 system. So if I add 5 here, 5 and 1, that's a 6 now. Minus 4 is 2. Right? It's funny how we're just so tempted to pop back into regular numbers. You just got to keep forcing yourself back into this weird foreign system. Base 5. So keep going from there. I bring that down, and you're ready for another one. I'll dive in. So what comes next? So now we're going into 3 into 24. So how many times does 3 go into 24?
4.
Yeah, you can say, you see these numbers, 2, 2 is the biggest amount that is under that. So we're going to go in there 3 times 4. So I'll do that. So 3, put the 4 over the last digit of the number we're going into, like usual. Okay. So then 4 times 3 is 12, but it's 2, 2. So 2, 2. And then what do I do? Subtract 2, bring down. I guess it's easier now. There's that first step that was super hard, huh? And then 2, 3. So now we're going 3 into 2, 3. Again, times 4, huh? So we go times 4. And that's 2, 2. Even though we think of it as 12, it's 2, 2. Subtract 1. That's the remainder. So remainder 1. So the answer is 3, 4, 4. Remainder 1. How we doing? This seem good? This making sense?
How would we write that on the homework, like if there's a remainder 1?
Yeah, they have these boxes. Yeah, see, they actually already put the remainder in there. They go, the answer is something, and they just gave you a bunch of remainder 0 problems. I'm doing ones that are a little harder than the homework. They just gave you some remainder 0 ones, so they already put it in there for you. It turns out. Good. Okay. So how many people got that last one? How are we doing on that? Okay, good. A lot of you. That is good. All right.